Hello friends, very good afternoon to all of you. I'm your host Dr. Sumant Kulkarni and welcome to our channel Genius Structures. We are dealing with slope deflection method. We have seen different types of continuous beams and different varieties, and we have solved these beams using slope deflection method. Today we are going to start with portal frame. Okay. So different types of portal frames will be dealt with in the further videos. So today we have taken a very simple frame, a single base single story frame, which is having 4 meter height of columns and moment of inertia as 1I, and beam is of span 3 meter, its I value is 2I, and the beam is completely loaded with UDL of 28 kilonewton per meter. So now we shall see step by step procedure to analyze this portal frame using slope deflection method. So let us start. So our very first step in slope deflection method will be finding out kinematic indeterminacy for this frame. So it will be 2. How to find kinematic indeterminacy? Always remember, you first of all neglect all the supports, that is this fixed end, you assume that there is no support here. So when any joint in space or when any joint of the frame is there, it will have 3 degrees of freedom. Each joint will have 3 degrees of freedom. Two linear translations, one in x, one in y direction, and other will be the rotation of this joint. So these 3 degrees of freedom will be there for each joint. So if the joints are free like B and C, if A and D is also free, then each joint will have 3 degrees of freedom. So how many number of joints are there? 4. A, B, C, D. So 3 into 4 is the 12 degrees of freedom for this overall frame. Out of this, the 3 degrees of freedom from this fixed end and this fixed end will be 0. Why? Because they are fixed. They are not allowed to have any degree of freedom. So 6 degrees of freedom will be deducted from 12. So 12 minus 6 is 6. Then how many number of members are there? AB, BC, CD. So subtract from this 6 value the number of members. Why number of members we have to subtract? Because these members are actually rigid. It is an assumption. Okay. So there is no actual translation which will be considered. It will be neglected. So 6 minus 3 is 3. Now from this 3 there will be sway of the frame. Either towards right or left. But this is simple frame. This frame is geometrically symmetric as well as loading wise also it is symmetric. So sway of the frame towards right or left is not possible. So you subtract this sway of the frame. So 3 minus 1 is 2. Okay. Initially it was 12. From this we have deducted this 3. So 9. This 3. 6. Number of members 3. So 6 minus 3. 3. Sway of the frame 3 minus 1. 2. Okay. So those 2 degrees of freedom are rotations of joints B and C. Simple. So this is our step number 1. Now step number 2 will be finding out fixed end moments. As far as fixed end moments are concerned, this particular frame is having external load on beam only. There is no external loading on columns. So fixed end moments for columns will be 0. Which are those values? MFAB then MFBA, then come to column CD. So MFCD and MFDC, so these are all 0. Okay, then MFBC is minus WL square by 12. So this is minus 28 into 3 square upon 12. So let us calculate this value. So 28 into 3 square upon 12. So it is minus 21. Okay, minus 21 kilonewton meter. Come to next part, MFCB. It will be plus WL square upon 12. So it is 28 into 3 square upon 12. So value is plus 21 kilonewton meter. Okay, plus 21 kilonewton meter. Now there will be next step. What will be next step? The slope deflection equations. Now we will have in all 6 slope deflection equations, but we are going to take only 3. Why? We are going to make use of one condition, symmetry of the frame. Geometrically as well as loading wise, the given frame is symmetric. It means whatever the rotation of joint B is there, it will be equal and opposite of C. It means theta B will be equal to minus theta C. Okay, if you draw a section line here or a mirror line, whatever the actions are developed on this left hand side of this line, equal and opposite actions will be on right hand side. Okay, along with the values will be same but directions opposite. So next step will be slope deflection equations. So let us write them. So now what will be those equations? Let us see. MAB will be first equation. MAB. What is MAB? 2EI by L into bracket 2 theta A plus theta B minus 3 delta by L minus MFAB. Okay. So carefully substitute I and L values for each member. So for AB member, I value is 1I, L is 4 meter. So let us substitute. So 2EI by 4 into bracket theta A is 0 because end A is fixed. Theta B is unknown. There is no sway of the frame. So delta is 0. MFAB 0. So simple 0.5 EI theta B. MAB equation. Okay, then MBA. What is equation for MBA? 2EI upon L into bracket theta A plus 2 theta B minus 3 delta by L plus MFBA. So what is equation? 2EI by 4 into bracket theta A again 0, 2 times theta B delta 0, MFBA also 0. So MBA equation is 2 into 2 4, 4 by 4 is 1. So it is EI theta B. Simple. Next, third equation MBC. What will be MBC? Equation again we will write first 2EI by L into bracket 2 theta B plus theta C minus 3 delta by L minus MFBC. So we will substitute the values one by one. Okay, so now we have to see for span BC. So I value here is 2i, so 2e into 2i divided by 3. Please remember, span of BC is 3, into bracket 2 theta b is unknown, plus theta c is unknown, delta 0, MFBC minus 21. Okay, minus 21. So what will be this equation? MBC, 2 into 2 4 by 3 into 2, so it will be 8 by 3. Okay, so what is 8 by 3? 2.67. so 2.67 EI theta b, plus next is instead of solving this or simplifying this, we will now make use of symmetry of the frame. What we will do is we will substitute here theta b is equal to minus theta c. Why? As just discussed earlier, because of symmetry, actions on left half of the frame will be equal and opposite on right half of the frame. So theta b will be equal and opposite. So theta b is minus theta c. So we will eliminate theta c. We will substitute minus theta b instead of theta c. So what is going to happen in this equation? 2 theta b minus theta b. So 1 theta b. Okay. So it is going to become 2 into 2 4 by 3 into 1 theta b. 4 by 3, which is 1.33. So I'll just change this equation, 1.33 EI theta b. Okay. Minus 21. That's it. MBC is equal to minus 21. Now what will be next step? Now we are going to stop this particular step here only with 3 equations. Remaining 3 will be equal and opposite of these 3. Okay. So we have to go to next step, equilibrium equations. Now how many unknowns we have? Only one. Theta b is minus theta c. So we have only one unknown, so we need only one equation. Okay. So equilibrium equations. So equilibrium equations will be on joint B we are going to see, because our unknown is theta b. So at B, what will be our condition? MBA plus MBC is equal to 0. Now what is MBA equation? EI theta b. MBC 1.33 EI theta b. So add these two. So this is 1 and this is 1.33. So total 2.33 EI theta b minus 21 is equal to 0. We will bring it on right hand side. So we will get from this equation EI theta b 21 upon 2.33. Let us calculate. In 21 upon 2.33. So it is 9.01. Okay. EI theta b is 9.01. Hence we can write EI theta c as minus 9.01. Simple. We have got both the unknowns. So we have reduced the length of the problem to a much extent. Just made it half. Now we will find final equations. Okay. Using slope deflection equations. We are just going to substitute back these values here. Okay. So step number 5 now. Step number 5 will be final moments. what will be these final moments? MAB. Let us see what is MAB. 0.5 EI theta B. How much is EI theta B? 9.01. So half of 9.01 is 4.5. Clockwise. Just let me cross check first of all. Yes, 4.5 kilonewton meter. Okay. Then MBA, what will be MBA? 1 EI theta B. So it is 9.01 kilonewton meter. Then MBC, 1.33 EI theta B. It means 1.33 into 9.01 minus 21. So it is minus 9.01 kilonewton meter. Now what will be MCB? MCB will be equal and opposite of MBC, because MBA plus MBC has to be 0 here. So from this we will get MCB as MBA. It has to be equal to opposite of MBA, equal and opposite of MBA. Okay, so it is minus 9.01. Okay, AB, DC, BA, CD. Okay, so MCB will be different. Fine. MBC, yes. So it will be plus, not minus. MBC will be equal and opposite of MCB, because theta B is equal and opposite of theta C. So this will be plus 9.01. Then MCD, you just have to look for mirror image of this frame. So BC, BA and CB, CD, BA and CD will be equal and opposite. So what is BA? 9.01 plus. So CD will be minus 9.01. Simple. And what about the final one? MDC, it has to be equal and opposite of AB. So minus 4.5. Okay. Minus 4.5. Now we will just show these values in the loading diagram. So MAB 4.5 clockwise. Then MBA clockwise 9.01. BC anti-clockwise 9.01. CB clockwise 9.01. CD anti-clockwise 9.01. DC anti-clockwise 4.5. Okay. Now one more moment value we will need. Since loading is symmetric, geometry of the frame is also symmetric. So what we need is point of zero shear force, which will be definitely at half of 3 meter. That is 1.5 from B or C. And there we have to find the maximum bending moment. So what we will do is, we will take free body diagram of beam BC, draw shear force, locate shear force, zero shear force, and then find bending moment value there. So let us do it. So symmetry has made this problem very simple. So let us take free body diagram of beam BC. So here we have these two values, 9.01 each. and this is loading diagram. The external loading, how much? 28 kilonewton per meter. Distance is 3 meter. So here these reactions will be half of the total load. What is total load? 28 into 3. So half of 28 into 3 is 42 kilonewton. And SFD will be something like this. Yes. So this is our shear force diagram, where point of zero shear force is at 1.5 meter from B. So here we have to take section and write moment value. So we will write equation, bending moment at x is equal to 1.5 meter from left hand side. So it is 42 into 1.5 minus 9.01 minus 28 into 1.5 square by 2. So let us calculate this value. So 42 into 1.5 minus 9.01 minus 28 into 1.5 square by 2. Value is 22.49. 22.49 kilonewton meter. I'll just note down here in red pen 22.49 positive. Okay, so it will be here. Now the question is where to plot these ordinates, on which side of column, on which side of beam. So for that we need to take help of these rotations or the directions of the moments, draw the deformed shape of the frame, and then plot bending moment values and complete the bending moment diagram. So let us do it. So I'll just now rub this. What we will do is we will just show first of all the direction of these moments. So see, here we have this clockwise movement. Now because of this clockwise movement, column at this end is going to undergo rotation on right hand side or deformation, something like this. What about this end of the column? Again clockwise, so on left hand side of the screen it is going to deform. So something like this will be the deformation of this column. Exactly mirror image of the right hand side column will be there as far as this deformed shape of the column is there. So it will be like this. Yes, this will be deformed shape of the columns. Now beam will be something like this. Yes, this is the deformed shape of the complete frame. It means 4.5 value will be plotted on right hand side, this 9.01 on left hand side, this 9.01 above the beam, this 22.49 below the beam, this 9.01 above the beam, this 9.01 on right hand side, this 4.5 on left hand side. That's it. If you understand how to draw deformed shape of the frame, plotting BMD for the frame will be very simple. Okay, so let us draw it. So 4.5 will be on right hand side. Then 9.01 here on left hand side. Here here the 9.01 value above the beam. Here also above the beam. Here on right hand side. So 9.01 value. Then this one is 4.5. Okay, 4.5 kilonewton meter. So join these two ordinates with straight line, these two ordinates with straight line. One more value we have to show, it will be at exactly midspan of the beam. Value is 22.49. I am going to show it below. Why? Its deformed shape is below. And joining these 3 points will be parabolically. Why parabolically? Because load is parabolic. Load is UDL. So for UDL, variation of bending moment diagram is parabolic, and for point loads it is linear. Okay, so these are our values. This is plus, this is minus, this is plus, this is minus, this is plus, this is minus. So this is our bending moment diagram. Over. So this is how we analyze a portal frame by slope deflection method. So guys, if you have any queries in drawing bending moment diagram or how to solve a portal frame by slope deflection method, this particular frame, if you have any questions, queries, do write in the comment. If you are new to the channel, please do subscribe the channel. Thank you very much.